Hi, my name is Leo Martins. I'm here to show you how Pontus Vision Thread Manager works. Pontus Vision Thread Manager helps accelerate all sorts of different types of business applications, and at the same time, it also helps reduce infrastructure CapEx and OpEx. Technology is also very easy to deploy, and it doesn't really require any code changes. The problem that we're solving with Pontus Vision Thread Manager is related to multi-threaded applications. When you have multi-threaded applications running on servers with multiple cores and multiple CPUs, location is one of the most important factors for performance. Depending on where the threads are running inside of a single server, communication can be over 100 times slower. The default behavior for an OS scheduler is to scatter the threads around, evenly loading all the CPUs. Whilst that's very easy for the scheduler to implement, it's very costly from an application performance perspective. Thread Manager solves this problem by analyzing constantly communication patterns between threads and in real time rearranging the threads so there are fewer jumps between CPUs and also as little context switch as possible. Now that really speeds up the applications, but at the same time it reduces the number of cores you're using in the system. The distance ratios within a single server, depending on where your cores are sitting, can vary dramatically, and that's what we're trying to optimize here. We have an FX pricing use case where we had 64 cores and 200 threads in the system, and the main reason why we don't think the operating system scheduler is capable of making optimal decisions is just the sheer complexity of the problem. The actual formula is the number of cores to the power of threads in the system. It's a big number. And when put it into perspective, it's much bigger than the total number of atoms in the universe. So trying to do thread pinning by hand is a very difficult task, and trying to do it fast enough within a scheduler is also very, very complex. The way Pontus Vision Thread Manager solves this problem is by running an agent on the target machine where you want to optimize, and then connecting that to a remote simulator. The agent sends two key pieces of information over to the simulator: information about the hardware and information about the software. The hardware information consists of details about the cores on the machine, which cores share level 1, level 2, level 3 cache, which cores share the same physical CPU, what are the QPI links like. The software information consists of which threads are communicating with each other. We're able to capture two ends of a socket or threads that are actually sharing the same shared memory area. When that information is sent to the simulator scores that current state of the system. So if threads that are talking to each other are physically present in faraway CPUs, that's a penalty. And then similarly, if you have too many threads waiting for the same core, that's a context switch, that's also penalized. That score is sent back to the agent, and through various heuristics, the agent is then capable of determining whether or not the system load has modified enough to warrant a new thread pinning strategy. If it has, the agent sends a signal to the simulator, which then runs millions of combinations trying to move threads from one CPU to another until it finds a better layout. Once a better layout is found, that information is sent to the agent, and then the agents in real time move the threads to more adequate solutions, to more adequate locations. This cycle happens continuously, making your system a self-tuning environment where any changes in thread behavior yield a new score and potentially a new simulation. And the longer you run the system for, the faster it becomes. The agent is capable of caching previous simulation results and then short-circuiting this whole cycle and applying them immediately. Hope this clarifies how Thread Manager works. Thank you very much.